Good morning, guys. This is Mr. T, and I'm going to guide you through the use of the equation that correlates the speed of light, frequency, and wavelength in this station. So looking at the equation right here, C represents the speed of light, or 3.0 times 10 to the 8 meters per second. This is a constant, so it never changes. The value of C is always the same. V represents the frequency in units of hertz or seconds to the -1, which is essentially the same unit. And lambda, that Greek symbol that you see there, which looks like an inverted Y, represents the wavelength, which can be expressed in units of meters or nanometers. Whenever we are trying to solve a problem that involves the use of the equation, we have to remember the triangle that we learned in class that correlates all three variables. In this case, C, or speed of light, is on top, lambda, or wavelength, is at the bottom left of the triangle, and V, or frequency, is at the bottom right of the triangle. So the first question that we have to ask ourselves when we solve a problem is, what are we trying to find? For example, if we are trying to find the frequency, highlighted in red here, we have to look at the variables left behind the triangle, in this case C and lambda, highlighted in blue. And what we have to do is simply look at the triangle and draw the resulting equation. In this case, C is on top of lambda, therefore the frequency V equals C over lambda. On the other hand, if we are trying to find the wavelength, or lambda highlighted in red here, again we have to look at the variables left behind, highlighted in blue, and all we have to do is draft again the equation as lambda equals C over V, because in the triangle C is on top of V. Now let's look at an example. The wavelength of green light is 522 nanometers. What is the frequency of this radiation? Again, we have to keep in mind using the triangle that we learned in class, and also that the speed of light is always going to be a constant number, 3.0 times 10 to the 8 meters per second, even if it's not expressly given in the problem. So having the triangle and having the speed of light, now let's look at the problem. What is the problem asking me? It's asking me what is the frequency of this radiation. Therefore, what I'm trying to find is a frequency, or V, highlighted in red in the triangle. On the other hand, the problem is also giving me the wavelength of light, which in this case is 522 nanometers. So basically, I have two things that I know, the speed of light and the wavelength, and all I have to do now is use the triangle to solve the equation. However, there is one last step that we need to do before going and using our calculator. This step has to do with units. As you can see, the wavelength here is expressed in units of nanometers, and the speed of light is expressed in units of meters. Meters and nanometers are not the same unit. Wavelength is in nanometers, speed of light is in meters. What's the value of the wavelength in meters? I need to convert the wavelengths to meters so that I can then use it in the equation with the speed of light, which is also in meters. In order to do that, I'm going to use a conversion factor. The conversion factor that we saw in class is that 1 meter equals 10 to the 9 nanometers. And what we're going to do is, as we learned in our dimensional analysis module, is convert 522 nanometers to meters using the cross strategy. So on top of the cross, we are going to put 522 nanometers. Next to it, the conversion factor, 1 meter over 10 to the 9 nanometers. All that's left to do is to cancel the units that we can. In this case, nanometers on top and at the bottom can be cancelled. And therefore, the resulting calculation is 522 times 1 divided by 10 to the 9. Plugging these values in the calculator, we'll get 522 times 10 to the minus 9, and the value is going to be meters. Now we can go back to the problem and remember that we are trying to find the frequency. Looking at the triangle, the frequency will equal C over lambda. We also know the speed of light, which is a constant, and we also know the wavelength, now converted to nanometers by what we just did. Using the values that we just got and replacing the values in the equation, we have frequency equals 3.0 times 10 to the 8 meters per second, representing the speed of light C, and 522 times 10 to the minus 9 meters, representing the wavelength that we just converted. All we have to do now is to cancel the units that we can. In this case, we have meters on top and meters at bottom, which are therefore cancelled. And then plugging the values in the calculator, we get our final result of 5.75 times 10 to the 14, 1/seconds, or hertz, which is the same unit. Now remember that we have to express the result in the correct number of significant figures. In this case, 522, which is the value for the wavelength, has 3 significant figures, and therefore our result will also have to be expressed in 3 significant figures, in this case 5.75. Remember that constants such as the speed of light in this case do not count when it comes to counting the number of significant figures.